This integration, if you see, is of the form integration of 0 to 1 x raised to m minus 1 1 minus x the whole raised to n minus 1 into dx. This integration is nothing but beta of m comma n. So we have y raised to half term, but we have 1 minus x minus y, but we want only 1 minus x term. That is, in our case variable is y, so we want only 1 minus y term, so that we can directly apply the function of beta of m comma n. So now recall your memories, and here this type is nothing but it is of the type beta, so we put y equal to 1 minus x, that is this constant, into some other variable, that is t. Why we are doing this substitution? When we put this here, we get 1 minus x minus y is 1 minus x into t the whole raised to half. So we can take 1 minus x common, so we get 1 minus x the whole raised to half into 1 minus t the whole raised to half. So this 1 minus t the whole raised to half is matching with this term. That's why we used to substitute this in beta and gamma function problems. So we put y equal to 1 minus x into t, so dy will be 1 minus x is constant into dt. Since we are changing the variable, our limits of integration will also get changed. Here we write initial variable is y, new variable is t. Y is going from 0 to 1 minus x. When we put y equal to 0 here, we get t equal to 0. When we put y equal to 1 minus x, so 1 minus x and 1 minus x will get cancelled, and we get t equal to 1. So now if you see, this limit is matching with this limit, so this is nothing but beta and gamma function only. So we have the new limits, that is going from t equal to 0 to t equal to 1. Y is nothing but 1 minus x into t the whole raised to half, so we have 1 minus x the whole raised to half, t raised to half, and this term we have simplified here as 1 minus x the whole raised to half 1 minus t the whole raised to half into dy. Dy is nothing but 1 minus x into dt, so here we have 1 minus x into dt, and this part will remain as it is. So first we will simplify this part. 1 minus x and 1 minus x is constant, so 1 minus x the whole raised to half and 1 minus x the whole raised to half will be nothing but 1 minus x. This 1 minus x and 1 minus x will be nothing but 1 minus x the whole square. This x raised to half we are writing here, and integration of x equal to 0, x equal to 1. Then we have t raised to half, t equal to 0 to t equal to 1. Then we have t raised to half into 1 minus t the whole raised to half dt. Now if you compare this term is matching with this term, so we get m minus 1 equal to half, which is this term, so we get m equal to 3 by 2, and we also get n minus 1 equal to half, so this is n is also equal to 3 by 2, so this part is nothing but beta of 3 by 2 comma 3 by 2. So our new integration will become integration of x equal to 0 to x equal to 1, x raised to half 1 minus x the whole square into dx, beta of 3 by 2 comma 3 by 2. Now consider this integration of x. This integration, if you closely observe, this integration is also matching with beta of m comma n, that is integration of 0 to 1 x raised to m minus 1 1 minus x the whole raised to n minus 1 into dx. So these terms are similar. When we compare, we get m minus 1 equal to half, so m is nothing but 3 by 2, and we compare this term, we get n minus 1 equal to 2, so n is 3. So this term is nothing but beta of 3 by 2 comma 3 into beta of 3 by 2 comma 3 by 2. So here we are going to apply the formula of beta of m comma n, which is nothing but gamma of 3 by 2 into gamma of 3 upon gamma of 3 by 2 plus 3 is nothing but 3 plus 6 upon 2, which is 9 by 2, into beta of 3 by 2 comma 3 by 2 is nothing but gamma of 3 by 2 into gamma of 3 by 2 upon gamma of 3. So this gamma of 3 and gamma of 3 will get cancelled, and gamma of 3 by 2 is nothing but half gamma of half, and gamma of half is nothing but root pi. So this 3 by 2 will be nothing but root pi by 2 into root pi by 2 into root pi by 2. And the gamma of 9 by 2 is nothing but 9 by 2 minus 1 is nothing but 7 by 2 into gamma of 7 by 2. Gamma of 7 by 2 is nothing but 7 by 2 minus 1, that is 5 by 2 into gamma of 5 by 2. Gamma of 5 by 2 is nothing but 5 by 2 minus 1, that is 3 by 2 into gamma of 3 by 2, and gamma of 3 by 2 is nothing but root pi upon 2. So 1 root pi upon 2 and root pi upon 2 will get cancelled, and we get root pi into root pi will be pi, and this half will get cancelled, this 2 and this 2 will get cancelled, and in the denominator we have 7 into 5 into 3, which is nothing but 105, and this 2 will go in the numerator, which will be 2 pi upon 105. So this is the solution of this integration, and this is how we solve the integration over a given area. So more such integration problems we will see in our next video, so stay tuned for our future lectures.